Okay? So remember I said there's three things we can do to change the number of pulses per image. Okay? Those three things include number of focal points. That's the one you guys know. Focal zones.
Focus
Remember I
on.
said you can change remember that's what kind of transducer lets you change what's the name of that transducer? What type of I'm not answering that question, asking that question really good. But the answer should be an array transducer. The array transducer means adjustable or multifocus, right?
Mm-hmm.
Okay? We kind of already know about this. We're changing the number of pulses per image. However many focuses we have, like if we have two focuses instead of one, it's going to take twice as long now to create that one image. What is the advantage of having multiple focuses though? Why would we need that? Why do we need multiple focal zones? What resolution is affected by that? Lateral resolution, guys. Remember, the focal zone is going to control the beam width. Lateral resolution is determined by the beam width, right?
Yep.
So instead of just a single beam, now we're going to have two beams with a small waist, right? Two beams with a small focus, okay, to create one image. Okay. Next thing is going to be sector size. You guys know how people change the sector size all the time, right?
Yeah.
All the time. When people do the aorta, don't they change the sector size to real thin? Okay. When you do that, you're deep. Instead of our image now being this big, all of these unnecessary scan lines, now it's this small, and now all I need is this many scan lines. So instead of say 8 scan lines, however many scan lines that I need to create that image, let's say I have a sector right there, I have a blunted sector like this. So instead of, put it on this side, I don't know, 1, 2, 3, 4, 5, 6 scan lines, now with a small sector, I only need 3 scan lines to create the image I need, because I'm only trying to see that little bit of information.
And that improves temporal resolution.
Absolutely.
Yeah.
Absolutely, it's going to improve our images. We're going to acquire images a lot faster. We're going to acquire
It's
images a lot
also
faster.
easy to elongate aorta.
Now it's easy. That's great, man. That's great. That's great.
And you underwork the machine, something like that.
Yeah, you do. You're not having the machine work as hard when you do that. Guys, y'all keep me on time. I don't know what time it is.
It's 11:03.
Oh, I got 10 minutes, huh?
How many?
I got 10 minutes, huh?
10 minutes.
This class in at 11:40, right?
I said 11:03.
Oh. I'm
Like,
talking about.
what?
I'm talking about. Let me. Yeah. I got plenty of time. Guys, the thousand line density. Line density. Okay? Line density is the third way to change the number of pulses per frame. There's actually a button or a toggle switch on the machine that lets you change the line density. Okay? Line density just meaning the space between these lines. So this space right here, that's our line density. The space, so every time you have that space, that's information that possibly could be missed that the ultrasound system has to kind of make up. Because we're going to talk about that as far as how we have scan lines, but we don't have any missing information from the image. Okay, but that's what sector line density is. Okay, so let's get deeper into them. So first one, guys, number of focal points or multifocus. An individual sound beam has only one focus. Y'all, this is the picture I was talking about. I don't have a little graphic on it though. Therefore, only one pulse is transmitted down each scan line. So this go and return, go and return, go and return, go and return, all the way across, right? All across this whole segment, right? So this one right here, go and return medium, go and return deeper. You got me? So now it's taking this one image, instead of just boom, 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 going back, now it's shallow, medium, deep on one scan line. Okay? When the technology uses multiple focuses or focal zones, more pulses travel down each scan line, and the number of pulses required to create an image increase. Okay? We're good there, guys? Questions, Mr. Silver? We're good there? Lauren?
So, can you go back? So it's mean with the multi-focus zone, the frame rate gonna be decrease.
It's gonna decrease.
Okay, got it.
It's gonna decrease. Remember, our three
Demo pulse.
our three all fall under number of pulses.
Mhm.
Our three things all fall under number of pulses. So it's gonna decrease. It's gonna decrease. Oh, what's going on with your pencil?
It's not working.
Alright, so the number of focal zones, yes, he's messing up our focus, our multi-focus, we're trying to focus over here. So multi-focusing decreases the frame rate because it takes, instead of one scan line per focus, now we're sending out a scan line per focal zone now. Okay? And it diminishes temporal resolution. Of course, guys, whatever frame rate does, temporal resolution is gonna do the same. Okay? If my frame rate is diminished, so is my temporal resolution. So, like this image, this is a bad image on here. You can't even tell any difference, right? But now that you can see this image really look like it has 5 focal zones, right? 1, 2, 3, 4, and 5 right there. So this image right here is gonna take 5 times longer than this image was to create. Because now it has to send out a scan line for each focus. Boom, 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 there and back. And before it goes to the next scan line next to it. Okay? This one's just gonna go.
Is that an option?
Yeah, it's an option. I have a video of it coming up actually. I have a video of it coming up.
That's
You
YouTube.
said that there's no difference between the first and second.
No, you can't tell on here. I'm sure on the actual machine it was a difference because what you're doing. Remember, we're changing our lateral resolution right here, right? We're improving lateral resolution with all of the. I've never had a machine where I had 5 focal zones going though. I never had the need for that, you know. So, but this is just an example. Of course, I wish I had like this machine actually showed the frame rate on here. I wish it actually showed the frame rate because I have a video where I'm showing you guys the frame rate that I made the other day. So we're talking about a single focus that's 1 pulse per scan line. That's going to have a shorter T-frame, right? It's going to take a less amount of time to create 1 image now, right? Because it's only going down 1 scan line and back to the transducer, right? Okay? It's going to have higher frame rates because of that. Because it takes a less amount of time to create 1 image, we're gonna create more images per second. Okay? Because it takes less time to create 1 image, we're gonna be able to create more images per second. Okay? And we're also gonna have temporal resolution because of the fact that we're creating more images per second. Okay? But we're going to have poor lateral resolution when we're comparing it to multifocus, because that's the whole purpose of multifocus, right? Is to increase lateral resolution, right? To have our beam narrower over a longer time. Okay, that's the whole point of multifocuses, lateral resolution. Remember, that was a question you guys answered for me on the test. What are you sacrificing when you have multiple focal zones? What two resolutions are being utilized? And remember, I had 2 different resolutions, and it was temporal resolution and lateral resolution when you're changing the number of focal zones.
Frame rate is low. You will have a low frame rate
When what?
with the multiple focus.
Yes, you're gonna have a lower frame. You're not gonna be able to acquire the images as fast per second. Remember, frame rate has a unit of hertz per second. Number of images per second. Okay. T-frame is just how long it takes to create 1 image. Questions? Okay. So again, multifocusing decreases frame rate, right? It's gonna take more time. You know, it decreases frame rate, meaning that we're not able to acquire as many images per second because of that fact. And it's going to diminish temporal resolution. But we're going to have better lateral resolution because of it. Okay? What is the main advantage of multiple focal zones? Better lateral resolution, guys. Better lateral resolution. Because the beam is narrow over a wide range of depths now. We're gonna have better lateral resolution. Okay? So when you think of focal zones, think of lateral resolution versus temporal resolution. You can actually change that on the IU-22. You can change that. You can go for speed, or you can go for detail. It's like a toggle switch. Speed and detail. Okay?
What is the speed you mean?
Meaning that I'm acquiring images a lot faster.
Oh.
Acquiring images a lot faster. Okay? Remember, there's a trade-off between temporal and lateral resolution when deciding to use more than one focal zone. Okay? This is my little video right here I made for you guys when I was at work the other day. You enjoyed it on Christmas break. Turn this up and do it loud. Doesn't that work? Oh man, this thing did not have one of those.
It's coming.
This toggle switch here is a dual function button, as you can see. Not only does it let us change our focal position by moving this toggle switch up and down,
Good, there we go.
this toggle switch here is a dual function button, as you can see.
See, it says focal
Not only
position.
does it let us
and
change our
focal
focal
number.
position by moving this toggle switch up and down, but it also let us change the number of focal zones on the image, which we know improves lateral resolution. Here, demonstrating one focal zone with a frame rate of 26. As I increase the number of focal zones, my frame rate is going to decrease because it takes more scan lines to create this image. Now with 3 focal zones, my frame rate is 10.
You should.
So it basically was like, went to like a third of the frame rate, right? 26 to 10 when we added 2 focal zones. So starting from 26 to 15 to 10 based on those focal zones. Hope that video was helpful.
Yep.
Unless I want to see it again, you know.
We have it on our sheets here,
What?
the one. No, or that's.
It is somewhere on there. I had to find it on IU-22. Okay, so sector size, guys. Remember, sector size is just. Remember, that's a button right on the front screen. That's the
Yeah.
middle button on IU-22. You can change the sector width, sector size, sector width. It's the same thing. Okay, so we have a wide sector right there, right?
Mhm.
And a narrow sector right here. With that narrow sector, we're gonna be able to get higher frame rates because look, narrow sector is 3, 6, 9, 10 scan lines to create that narrow sector. 3, 6, 9, 12, 15, 16 scan lines to create that image. Right? So now we have less scan lines, therefore our frame rate is gonna be higher. Okay? When the user expands the sector size, also known as the field of view, more pulses are required to create an image. So when I put wide scan on, I'm decreasing my temporal resolution, right? Say for instance, I can't see the dome of the right liver. I can't see that dome of the right liver, and I need to put wide scan. Or if I'm looking at the left liver and and it's too wide, and I need to put wide scan on. Now I'm decreasing the temporal resolution now because now I'm adding scan lines to my image. So it's going to take longer to acquire this wide scan image now. Again, we can't see that, right? Because our eyes aren't able to detect that speed because sound moves so fast. But this is the science about what's happening with it. Okay? With our eyes, wide scan and narrow sector width, it's still moving in real time to us. Okay? But in actuality, it's really not. It's moving slower when you have wide scan on compared to when you narrow the field of view. Question mark? Any questions? I wouldn't say it's more grainy. We're just talking about time. We're just talking about time. Grain has to do with speckle, noise being created on the image. That has to do with constructive and destructive interference coming back to the transducer. We'll talk about that down the line. Right now, this whole chapter is just based on time. It's the time it takes to create images. The number of images we can create in 1 second.